Okay. Hi everyone. My name is Andrew Mo, and this is my presentation for going over my physics 21-22-12 lab 1 results. So the goal of this lab is to basically prepare charged pieces of clear tape and observe their interactions. And using these interactions, we want to determine the amount of excess charge on the piece of tape. And the purpose of this lab is to basically understand how ordinary objects can acquire excess charge under normal conditions, and to also learn about basic electrical interactions between charged objects. And so there are basically three fundamental concepts that are applicable to this lab. So the first is Coulomb's law, which basically states that which basically allows us to quantify an electrical force between two charged stationary particles. And the other two fundamental concepts are Newton's second and third laws. And so for our model and our system, we basically created or made two U-tapes that are created from quickly pulling tape off of a base tape. And we tested the charges of these tapes by observing interactions with our hands, negatively charged pens, etc. And we basically determined that the U-tapes are positively charged. And we basically constructed two of these charged U-tapes and observed their interactions by first placing a U-tape on top of two objects of equal height such that the tape is suspended like a bridge. And we place the second U-tape below the suspended U-tape until it starts floating, like the diagram shown on the right. And so there are a few assumptions that we made for this lab. So the first is that each U-tape piece is a point charge. The second is that the tape's charge is located at the center of the tape and that both tapes have equal charge. And the last one is that there is zero air resistance in our system. And so there are a couple of expectations that I had coming into this lab. The first is that the tapes would repel each other due to their similar charge state. And the second is that the tape would float indefinitely if no other forces acted on it. And so after conducting our lab experiment, we were able to collect a variety of data points. So these are some of the data points that we got after our lab. And with these data points, we were able to calculate a variety of useful values. And with these values, we were able to calculate the number of excess electrons, which was 9.93 times 10 to the 10. And using that, we were able to also get a ratio of excess electrons to atoms. And so this is the glow script code that helped us get the values that were calculated in the previous slide. And it also allowed us to basically model our system that was described a few slides ago. So this is code. And after running our code, this was the model of our system with the tapes represented as point charges and the arrows kind of showing the different forces that exists on the tape due to the interaction between these charged tapes. And so kind of in conclusion, we used a variety of physics principles to calculate the charge and excess electrons on ordinary objects. We were able to use Coulomb's law to help us find the charge and excess electrons. And we were also able to use Newton's second and third laws to help us find the electric force. And we also learned that particles with the same charge attract and the opposite charges repel. And so there were a few potential sources of error that could have arisen in this lab. One is just basic human error from the measurements, and the second was just assumptions that were made. And so this is the answers to some of the lab questions. So for the first lab question, I answered it by saying that if electrons had positive charge and protons had negative charge, then it would not change the observations that I made from the lab and other charged objects. The charges on the tape would still remain the same regardless of whether or not it was positive or negative. Therefore, because they are the same charge, they will repel each other. And for the second question, I answered it by saying that it is important to handle the charged tapes as little as possible because the charges are extremely susceptible to being transferred from one object to another. If it comes into contact with other objects, the charges are transferred and the objects will return back to its original unchanged state. Therefore, we want to handle these charged tapes cautiously. And yeah, that's my lab. Thank you so much.